Okay, let's continue, and we can start just by our last little task that we had before the break, looking at this question about what would happen if we had a for loop adding these different numbers together. And let's see, did people actually fill in some responses here? It looks like, yeah, there were some responses here. So we had 14 answers. The most 15 answers, sorry, the most common being 11, 7, 11, 15, 11, and then one syntax error. So here we have our code, and conveniently enough, we can simply just copy and paste it in here and run this, and we get back 11, 7, 11, 15, and 11. And breaking this down, it sort of makes sense. We're going through our list of odd and even numbers. You take the first value from odd numbers list. 1 plus 10 is 11. 3 plus 4 is 7. 5 plus 6 is 11. 7 plus 8 is 15. And 9 plus 2 is 11. So again, same kind of thing we saw before with the capitals and the countries, but now we're just adding these numbers together. And when you have corresponding lists of different kinds of things, then this is a sort of typical approach to use for that kind of problem. So that's more or less it for the for loops. Any questions about this one or this example? All right, then we can go back to file browser here for a second and open up our other notebook for today about conditional statements. And I'll just hide the file browser so that we can see that. I don't know why it scrolled me all the way to the bottom of the notebook. But we've learned about for loops first, which is a way of kind of going through and iterating over a list of items, for instance, in a Python list and doing something with them. And now we're going to learn about conditional statements, which are essentially ways to make decisions in your code about what parts of the code get utilized. And in our first case here, we have a temperature, 17 degrees, and we want to make a conditional statement that says, if the temperature is greater than 25, print the temperature is hot. Otherwise, print the temperature is not hot. So we can do that with a conditional statement by saying if, and then temperature, is, let's say, greater than 25. As we said here, if the temperature is greater than 25, print the temperature is hot. I'm just going to move this comment to be above our code. And our instructions were print. And let's make another F string because we can get more practice with those. And put in here, temperature is hot. So this looks a little bit like what we were doing with the for loop stuff before. We have an if here and then a variable. And we'll go through this in just a moment. And then otherwise, print the temperature is not hot. So then we can have here, for instance, else. And then another print statement, another F string. And again, let's put in here, temperature is not hot. And our temperature is 17 degrees, so our expectation is that this should be classified as not hot. And when we run this, sure enough, we get the output that 17 is not hot. So what happened? Well, we assigned a temperature. So variable temperature gets a value of 17. Then we have this if statement, and it's just checking to say, okay, if, and then here is some condition. This is why these are called conditional statements. Our condition is that temperature is greater than 25. Anytime you have one of these conditions, it should essentially return a true or a false value. And when we say temperature is greater than 25, we can look at this. 17 is greater than 25. No, that's not true. That's false. So this is going to be false. For this if statement, if it gets a false value for the condition, It does not execute the code that is underneath the if statement, but instead jumps to the else case for what happens when if is false. And then it prints out that temperature is not hot. So in this case, 17 is not hot because it puts in the value of that temperature. Logically, this is not perhaps that complicated, but it'll take us a little bit of practice to get used to using these kinds of conditional statements. We could, for instance, copy what we have here. Oh, yeah. Where is the... Okay. Okay. So yeah, let's copy what we have in our first cell that hopefully is working for everybody now. Paste it down here and just change our temperature. Let's make it 30. 30 is greater than 25, so we should now pass the first test here and print this out, which means once you pass the first test, none of the other kind of else or anything like that will get executed, and when you run this one, you get 30 is hot. So logically, this is kind of like you have a condition here, if, and some condition. If the condition is true, this code gets executed and the else gets ignored. If this condition is false, this code gets ignored and whatever is under the else will get executed instead. And the basic structure is a lot like what we saw with a for loop. We have if instead of for, but we have this sort of if statement. Then we have here a condition, some kind of comparison usually between different values. So temperature being compared to the number 25. Of course, our comparison operator here is this greater than symbol. And then indented beneath the if statement is the code that we want to execute if that condition is true. In this case, we say whatever that temperature is hot. If this condition is not true, we include the else statement here to catch that case. And here then is the code that would get executed if the else condition is met, which means the if is false, then this gets run and we see that the temperature is not hot. And just the opposite in the case down below when we make the temperature hotter. This condition is now true, so we execute this print statement and ignore the stuff under the else. It is possible, of course, to have if statements that don't include an else. So we could say, for instance, temperature equals 17 again, and say, let's just copy the first part of this from above to just save a little bit of typing. So if temperature is greater than 25, print temperature is hot. When you run this cell, you'll get no output. And that's because we don't meet this condition. 17 is not greater than 25. So this print statement does not get executed, but there is no else given, so nothing happens. So it's not an uncommon thing in a code that you say, okay, well, if this condition arises, do something, but otherwise just keep going. And it kind of makes sense here that if this condition is not true, we don't do this, but we don't give an alternative for what to do otherwise. Maybe one thing I can just emphasize here regarding these comparisons is if we just add an extra cell here and paste in this condition that we're checking, temperature greater than 25. If you run this just by itself, you can see you get back false, as 17 is not greater than 25. And the way that these logical things work with our if statement, we just want to check and see something that gives us either a true or a false value. If we changed our comparison to say 15 degrees instead of 25, 17 is greater than 15. So you run this, and now you get true. There are a few other comparisons we could give, like we can do greater than or equal to. Of course, this is still going to be true for 15. But if we had, for instance, 17 here, we could see that 17 is greater than or equal to 17. But if we just said only greater than 17, we get a false here. So we'll show you some of the different comparisons you can do, the different operations later down in the notebook. But the point is that whatever this comparison is, it should return true or false. It shouldn't print something. It shouldn't calculate some value. It has to be true or false in order for this if and else kind of logic to work. Now, just relating things to everyday life, you can think about maybe something like this weekend when there was a lot of rain, and make a decision about what clothing you want to wear on the basis of what the weather conditions are. So here we have the weather conditions are equal to rain. We say, if the weather is rain, print wear a raincoat. Otherwise, print no raincoat needed. So let's convert that instruction into Python code by saying if, and we'll say weather, and then we'll do equals equals, and then quote rain. This double equal sign here is the way in which we compare to check and see if a value is exactly equal to another value. So now we're checking to see if the variable value for weather is exactly equal to rain. A single equal sign will be trying to assign a value. So a double equal sign is telling us that we're comparing things. And our instruction here was that we should say print wear a raincoat. And then underneath here, we have this otherwise, print no raincoat needed. The otherwise is a sort of same thing as else. So if this isn't true, then what we should say is print no raincoat needed. So here we're going to check and see what our weather conditions are. If weather is equal to rain, we're going to print wear a raincoat. Otherwise, we're going to see that no raincoat is needed. And as you can see, when you run this, the weather value that we assigned right here is equal to rain. So we're told that we should wear a raincoat. You probably do this without thinking about kind of the logic of what you're doing. You're not mentally going through and writing Python code in your head to make a decision. You're just looking outside and you see it's raining and you say, okay, I probably should wear a raincoat or bring an umbrella or whatever. But regardless, the kind of idea is the same. You're essentially making this logical decision. You look outside, it's raining, I'll wear a raincoat. It's not raining, I'm not going to need a raincoat. So this is a kind of familiar thing, I would guess, in some ways. So we have our same kind of structure, if, some comparison, colon, and then indented stuff underneath here for what happens if this is true, and then else, colon, what happens if the if statement is not true. Again, you'll notice that if you don't indent things underneath here and run this, you'll get an indentation error that says you have an if statement here, and we expect the code to be indented underneath an if statement. I think you can also get syntax errors in some cases depending on how you set things up. I don't remember off the top of my head how to make a nice syntax error here. But another thing here is when you're doing an exact comparison, saying weather equals rain, you have to worry about the fact if you're comparing text that capital letters and lowercase letters are not seen as identical in Python. So if we had written capital R for rain and we run this, it's big R, which sounds like even more important, like heavy rain. And yet we're told not to wear a raincoat. And that's because our comparison doesn't handle the case of the text not being in what we would want, which is sort of case insensitive. So it mentions just down here that what we could do is say if weather dot lower equals rain, because this dot lower it's a built-in method for working with text strings that puts the text into lowercase. So even if we wrote, rain, like it's really bad rain, this now works because it will take this capital rain and make it into lowercase before comparing the things. This is just kind of a little side note here, because when you do exact comparisons, you have to be a little bit careful in many different programming languages. Some of them, if you compare a value to being exactly equal to 0, that can be dangerous. But when you're comparing text, it's often the case you want to make sure that if somebody, like you maybe have run programs before where it asks you to say yes or no to something that the code's asking you about. If you put a capital Y in yes, it might ask you no. I asked you to put yes in lowercase or no in lowercase. This allows our code to be a little bit more flexible by using this dot lower thing here. So it's just a kind of note for how these comparisons work. Which takes us here now to a question. So if it's a particularly rainy day like it was for some of the days this weekend, we might not only need a raincoat, but we might need to wear also some rain boots. And your task now is to modify the example we have above here to tell us to not only wear a raincoat, but also to wear rain boots if we have the weather equals rain condition. So you can maybe put your code in here. I don't think there's anything to do in terms of a poll question here. Yeah, this is just something for you to type in yourself and see if you can modify the code logic for this if statement to print these two things out if it's rain or the conditions we have. So maybe I will start kind of slowly going through this, but the basic idea is I just copied and pasted what we had above. I put our rain back to lowercase and deleted the dot lower thing here, but I just copied what we had in the cell above where we were told when the weather was rainy to wear a raincoat. And when I run that, okay, I get wear a raincoat. The only modification you need to be told to also wear rain boots is to add a second print statement whenever this condition is true. So we could say wear rain boots. Not books, boots. Here as a second thing that gets printed to the screen. So when this condition is true, it does both of these things. And now when you run it, when the weather conditions are rain, you see wear a raincoat and wear rain boots. So sort of a simple modification to make in a sense, but just emphasizing to you that if you have multiple lines underneath one of these if conditions, you could have many different things happen inside your program. As long as they are indented, whatever is indented here will get executed when the if condition is true. Again, if it was, let's say, sunny instead of rain for the weather conditions, we would see that no raincoat is needed. So things work just as they did before, except now we get these two things printed when the weather conditions are equal to rain. So I mentioned before these comparison operators. So we have equal to, like we were just using, which is comparing to see if two values are exactly equal to another. There's an example here, for instance, cat equals dog, and that of course comes back as false when it's evaluated. But there's also not equal to. So you can check and see if a value is not equal to something. So cat does not equal dog, of course, will evaluate as true. Then there's less than, greater than, less than or equal to, and greater than or equal to. And there's some examples of how those work in the table that you can see on the course page and in the notebook here. But just showing us that we can compare values in several different ways. And I think I've already shown an example of what the output are for these statements when you have something where you evaluate and you say, okay, the values are true or false. I think I actually already showed even this example of temperature greater than 25. And that evaluates as false. And the reason that evaluates as false is if we were to print out the value of temperature first, we see temperature has a value of 17. And of course, 17 is not greater than 25, so that condition statement is false like we saw earlier. Same thing is true that if we said weather equals rain, the last time we ran that code cell, we had said weather is equal to rain, so of course this comes back as being true. And just if you wanted to confirm, you could scroll up here and see, yep, we assigned weather to be rain a couple cells above. So one thing we haven't seen yet, we've seen what happens to code when one condition is true and what happens when that condition is not true, if and else. But there is a third possibility as well, and that is to have this else if condition, where we can add in another test that happens if the if condition is not true. So here we have a temperature of -3, and we have code that says, or a cell that we're asked to put in some code that says if the temperature is greater than 0, print that the temperature is above freezing. If it's exactly 0, print that it is freezing, and in other cases, print that it's below freezing. So if temperature is greater than 0, print is above freezing. Okay, let's do that. If temperature is greater than 0. That's our condition, easy enough. Temperature greater than 0. What are we going to do? We're going to print out, and we'll f string this, that temperature is above freezing. So that's what happens if our temperature value is greater than 0. But since we want to handle the case of temperature being above freezing, temperature being below freezing, and temperature being exactly equal to freezing, we need 3 options, not just if and else, although we could string together things to do things like that. So then there's this else if, which in Python is elif. And with elif, unlike else, it expects you to have another comparison there. It's saying, okay, well, if the first case wasn't true, then what about if this case is true? So else, if this is true. Temperature exactly 0, print that it's freezing. So here we could say temperature equals 0. In that case, we know that our print should be that temperature is freezing. Because in that case, our temperature is 0, which we'll say is freezing. Logically, if the temperature is not greater than 0 and the temperature is not exactly equal to 0, it must be below 0, right? So in the final case, we can simply have an else statement here. We've ruled out the possibility of it being above 0 or 0 exactly. If we've gotten down here, it must be that the temperature is below 0, and our print statement could be that temperature is below freezing. So we have these 3 different cases here. In each of the first 2, we have a comparison that's going to evaluate as true or false. If our temperature is above 0, we're going to print out that the temperature is above freezing, and these other things will just get ignored. Essentially, with these if and elif and else conditions, the first one that you hit that's true, that gets executed, and everything else in the set gets ignored. So if this condition is true, the elif doesn't get evaluated and the else doesn't get evaluated. If this is false, so if the temperature is not greater than 0, then we're going to jump to the next test. Is the temperature exactly equal to 0? If that's true, this print statement will get executed and the else will get ignored. And otherwise, we continue down to the else condition. Our temperature here is -3. And when we run this, we see -3 is below freezing. Okay? Seems like this is working, but let's test out other possibilities. What if we take away the negative sign here? Temperature equals 3. Let's run this one. We get 3 is above freezing. That also looks promising. And just to check that our elif condition works, we could set the temperature equal to 0 and run this and see that 0 is freezing because temperature is exactly equal to 0 and this condition gets executed. I just wanted to mention that, or maybe kind of emphasize the order in which these things happen so that you're aware that once you pass one of these conditions, the other ones don't get executed. Because sometimes when you start setting up things in your code, you might think, okay, well, if this condition is true and this condition is true, that both of those things will get executed. This could very well be true. But the first one that gets evaluated as true is the only thing that gets executed, and the rest in the chain will just get ignored. So if we had modified this, and I'm not suggesting that that you need to necessarily do it, but let's say that we had a situation like this. If temperature is greater than 0, that's true. And then elif, temperature is exactly equal to 3. Well, this is also true. But when we run this, only the first one passes as a true statement. So even though this would evaluate as true, because the first if statement was true, the elif and else just get ignored. If you wanted to check that the second condition was true, if you take away the L in the elif, this then becomes a separate if statement, so that this can be true and this also can be evaluated because it no longer depends on what happened in the first test. This is sort of an independent if test. And if we run this, then we see that 3 is above freezing and 3 is freezing. Okay, well, our text doesn't make a lot of sense here, but logically, because this is one if statement and this one is independent, both of those things can get written out to the screen. But if that was elif, it's no longer independent of the outcome of the first test. That might not totally make sense, and that's fine. It's just something that may come up in working on the exercise. When you start thinking about the logic of these things, sometimes you need to check and see, okay, do I want to make sure that this condition gets caught every time, or is it depending on the outcome of the first test? In our case here, it doesn't make any sense to have this be a separate if statement to check if the temperature is exactly equal to 0. All right, let's have a look at one more question here. So let's assume it was 14 degrees C yesterday, 10 degrees C outside today. It's maybe a little bit warmer than 10. And tomorrow it'll be 13. The following code compares these temperatures and prints out something to the screen based on the comparison. So we see yesterday's 14, today's 10, tomorrow's 13, and then a bunch of if, and then print A, B, C, and D. The question for you is which letters of these 4 would be printed out to the screen when you run this code? And for this, there is a question that you can use the polling page to answer. So please take a moment to answer the question, and then we'll continue once we have your responses. All right, so we have, I think, 16 responses now to our question about which of these letters would get printed out to the screen. And if we look at the responses here, we have B and C, we have only B and only C as the different choices. So let's have a quick look at what we would expect to see here. So we have our three values that are assigned. So if yesterday is less than or equal to today, print A. So yesterday is 14, today is 10. So this is not true that yesterday is less than today. Then we have if today is not equal to tomorrow. So today is 10, tomorrow is 13. So they are not equal to each other, which means that we would expect B to be printed out to the screen. In this case, we're done, basically. These other elif conditions will be ignored from here onward because we have passed one of the tests and the rest of the chain of tests will not get executed. So even though yesterday is greater than tomorrow, that is true, this doesn't get printed because once one of the tests in this set of if and elif conditions is passed, the rest of them don't get executed. So again, as the majority selected, B is the only thing that would be printed out to the screen in this case. And again, if you want to just verify that for yourself, you can copy paste the code into the code cell there, and you'll see that B is the only value that gets printed out. As I mentioned, if you wanted to check all of these conditions independently of one another, you could delete the L in the elif, and then have 4 independent if statements. So this would check this condition, this one checks this condition, the third checks that condition, and the fourth checks that condition. And in that scenario, these are all separate from one another. So if one is true, it doesn't matter for the others, and we see that we get B, C, and D printed out because these three have true conditions. Only A is false. But when you write these out of if and elif, it's once the first one is passed, the others get skipped over. So one other thing we can talk about here is combining conditions. So sometimes you want to check to see whether this is true and some other condition is true. So there's a little logic table thing that's given here showing, for instance, the AND operator that will be true if both comparisons are true. So 2 greater than 1 and 1 less than 0 would return false. 2 is greater than 1, that's true. But the AND operation requires that both this test and the second test, 1 being less than 0, is true. And again, if we just copy this, add a cell down here, we could just check these cases. So 2 greater than 1 and 1 less than 0 does in fact come back as false. And this is basically because what happens here is that this gets evaluated as true, this gets evaluated as false, and with the way that the logical AND operation operates, it's true only if both parts are true. So when we run this, we get false back. If we do the same thing with OR, this says that if this condition is true or the other one is true, the evaluation of the set of conditions will come back as true. So again, if we copy this one, 2 is greater than 1, that's true. 1 is less than 0, that is false. But OR says that either one is true, then the output or outcome would be true. And again, this is basically saying, okay, this condition is true, this condition is false, but if either one is true, then it comes back evaluating as true. And finally, NOT is something that can be used to check if a condition, it basically just flips it. So if it would evaluate as true, it flips it to false. If it evaluates as false, it would flip it to true. So the example that's given here would say not 2 is greater than 1. So this is true. But if we say it's not true, then it has to be false, which is why when you run this, it evaluates as false. So this is essentially what's going on in the Python. Is saying it's the opposite of true, which is false. And of course, the opposite of false is true. So sometimes you use this not condition to check and see if something is, it's not the case. So you could check and see that the temperature is not above freezing, in which case it means it must be below freezing, and then maybe you could have a print statement that says, be careful, it might be slippery, or something like that. So we have an example here of a hot temperature of 35, warm temperature of 24, and a cold temperature of -4. And using the temperatures above, create an if statement that uses the and keyword with two conditions. If true, print both parts are true. If false, print at least one part is not true. So we have here, if hot temperature is greater than warm temperature. Let's see, is that true? Yes, it is, right? 35 is greater than 24. And cold temperature is greater than warm temperature. So -4 is greater than 24. That's false. So in that case, we should print out both parts are true. And otherwise, we should print at least one part is not true. Both of these could be false, but we only know that at least one is not true, because in order for it to be true with an and operation, both parts have to be true. And when you run this, you get at least one part is not true. And here we can tell that this test is the one that is not true. So small kind of Python style thing here. It's common when you have these and operations where you have multiple conditions that you put your conditions you're comparing in parentheses. It just makes it a little bit easier to see what things are actually being compared between each other. I don't think this is necessarily a kind of Python standard, but it's at least something I like to do just to kind of be able to easily see when I have a whole long line of like different comparisons to see which ones are being compared. So here I can see, because of the parentheses, hot temperature and warm temperature being compared, and cold temperature and warm temperature being compared here. So if we take our statement from here above, we modify the statement to use the or keyword. And if true, we can say at least one part is true. Let's just paste this in here, what we had above. So if hot temperature is greater than warm temperature, or cold temperature is greater than warm temperature, we print that at least one part is true. In the case that we fail this or condition, that means that both parts are false, logically, right? If we have to have one or both of these be true in order to get this to be printed out, which is basically what the or statement says, it's either this is true or that's true or both. If that's not the case, then we know that both parts are not true. And when we run this, we have the same temperatures we used before. We have the same comparisons we had before. Hot temperature is greater than warm temperature. That's true. So we get printed out at least one part is true. If we, for instance, flip this, instead of saying hot temperature is greater than warm temperature to be hot temperature is less than warm temperature, that's now false. This is also false. And when we run this, we now get both parts are not true, because false or false will result in a value of false. But as it was written, we had hot temperature greater than warm temperature, so that was true, and that's why we get at least one part is true as our output. All right, we have another question here. And I think maybe I'll just walk you through this one because, well, no, actually, I think you guys can, we have enough time to do this one, so let's do it. So we had our decision about rainy day. And it was basically, if the weather conditions are rain, you should wear a rain jacket, and wear rain boots. Now we're going to consider also the fact that it could be windy and rainy. And if it's windy and rainy, we're just going to stay at home. And in this case, our decision that we're going to make has to do with what we consider a comfort limit for how windy it can be. So if the wind is greater than 10 meters per second, it's pretty windy and it's no longer comfortable, so we're just going to stay home. Your task here is to modify things such that if it's windy or rainy, you just stay home. Otherwise, you go out and enjoy the weather, because if that's the case, that it's not windy or raining, it's presumably not too bad outside. So you can use this cell to modify the tests that we had earlier to check and see if it's windy or raining. And if either one of those is true, you can say that you should just stay at home. And otherwise, you can print, go out and enjoy the weather. So why don't you take a minute or two to try that out, and then we'll continue. All right, let's see how we can do this. So the task was to assess whether it's windy or rainy, and then just stay at home if that's the case. And our first step in doing this is to perhaps assess whether we consider it to be windy or not. And in this case, the windy means that the wind speed is greater than our comfort limit. So we could, for instance, say that if it's windy, so that means that wind speed is greater than our comfort limit. That would allow us to say, okay, it's windy, let's just stay at home. But with what we've learned, we could have in a second, or add in a second condition. And because we're going to have a second condition, I'm just going to put this in parentheses for readability. And so now we have a condition that if the wind speed is greater than comfort limit or weather equals rain, then we're going to have our print statement here that says whatever it was, just stay at home or stay at home. Or whatever you want to write. If this condition is true, or that condition is true, or both, this will get executed. Otherwise, if it's not windy and it's not rainy, then we're going to print out that go out and enjoy the weather. Because in order for us to get to this else statement, it means that neither one of these things could have been true. Looking at what we have here, we can see it's rainy, we can see it's windy. So when we run this, it's no surprise that we get stay at home today as the output. If we lowered the wind speed, for instance, to 4 meters per second instead of 14, and run this again, well, we still get the same output because it's still rainy, and we've kind of decided that if it's rainy, we're not going to go out and enjoy the weather, but just to stay home. But if we said instead, now it's sunny with a wind speed of 4 meters per second, this meets our criteria to be considered good weather. And now when you run our tests here, we see go out and enjoy the weather. And the reason for that is that the wind speed is not greater than the comfort limit, and the weather is not rain. So if both of those things are false, then we go to the else condition here, and we get go out and enjoy the weather. All right, last thing, combining for loops and conditional statements. So we saw in the previous part of the lesson about for loops, and we can use the combination of for loops and conditional statements to do some pretty useful things, like go over a list of temperatures and classify them as hot or not hot or whatever. So we could say, for instance, the that we have a for loop, and let's just say for temp in temperatures. So we'll just directly use the values from the list rather than using the index to refer to them. Inside our for loop, for each one of these temperatures, we could say that if the temperature is greater than 25, print that temperature is hot. So if temp is greater than 25, print, and let's just do an F string for fun, temp is hot. So same logic we were using before, we're just now putting it inside of a for loop to compare against a list of temperatures. For the sake of completeness, we could add an else condition here. So if the temperature is not greater than 25, we'll print out that our temp is not hot. So what this should do is take us through with our for loop. Each value from temperatures, assign that to the variable temp. So the first time temperature should be equal to 0, or temp should be equal to 0. This is the first value in the temperatures list. We'll do a comparison. Is temp greater than 25? No, it's not. So we should expect to see 0 is not hot. Then we go to the next temperature in the list and do the same thing over and over until we go through all 5 of our temperatures. And we get the output here that 0 is not hot, 28 is hot, 12 is not hot, 17 is not hot, and 30 is hot. So this would allow us to classify temperatures into several different categories if we wanted to. We could have a string of different conditions that we check. Okay, is it hot? Well, maybe if instead of just if it's hot or not, we could say, is it warm? Is it comfortable? Is it freezing? Is it whatever? We could repeat this for different conditions, and that's something we'll do in this week's exercise. But are there any questions at this point about the kind of combining conditions, for loops and conditional statements, anything like that? Of course, you'll get chances to work with this stuff in the exercise this week. All right. One thing we can look at before we go to this week's exercise is our good coding practice, which is actually, I think, one of the more useful ones about writing readable code. So we've had 2 other good coding practices. We had the first one about choosing good variable names, the second one about adding comments to describe what your code does, and the third one now makes sense to come up in this week's lesson about writing readable code, because this is about how we format the Python code to make it more readable. And there's a nice comic here about somebody who's a self-taught programmer and someone else looking at their code, and at least I sort of find the second one particularly amusing, about them looking at the code saying it's like a salad recipe written by a corporate lawyer using a phone autocorrect that only knew Excel formulas. So it's essentially describing the code as just an absolute mess. And for self-taught programmers, that is often the case, that if you're not given any guidelines about how to format your code, it just becomes a disaster. Which is part of the reason in Python why these kind of indentation blocks are forced on you, is that does help to format your code. But there's more than that that's available in Python, and in particular, we'd like to draw your attention to this PEP 8 style guide in Python that you can find at the link here, that gives you essentially recommendations for how to format your Python code. And there's a bunch of details in here, but it goes through things like indentation. What's the guideline in writing Python code? Okay, well, it's pretty clear. Use 4 spaces per indentation level. You don't have to use 4 spaces. You can use 3, 2, 6, 8, whatever. But the expectation in Python code is that it should be 4 spaces. This just makes things easy to read, and then they go through some examples about how to do this in the correct and incorrect forms. We have a simplified version of that on the course page, talking about things like maximum line length, indentation, white space, and things like that. So for the line length, the guideline for the PEP 8, which is Python enhancement something. I never remember what PEP stands for. Python enhancement proposals. But here they say 79 characters is as long as you should have text on any one line. That's the PEP 8 guideline. Notably on our web page, we use up to 88 characters in the length of the lines because sometimes it just makes it a little bit more readable, especially on the wide format for the web pages to have 88 characters. But 79 is what's recommended and suggested to follow that, to not have super long lines of 200 characters that are then difficult to see on the screen together. So there's an example here showing how to take a long list and wrap it so that you can have the values formatted nicely to be able to see all the values in the list on only 2 lines. As mentioned about the indentation, there's 4 spaces per indentation level. So you can see, for instance, with some example if statements here, how that works. It's also possible to break things onto multiple lines if you need to. So if you would have a really long line because of a couple comparisons, you can break the lines and do things like what's shown in the example here. And you're somewhat flexible when you break a line like this, whether you want to have it indented 4 spaces or a little bit more. Sometimes it's easier to tell if these are related to the same if statement if you indent them to a different level than the print statement beneath it. But there's some examples you can see on the course page about that. Then there's some comments about white space, which is essentially just blank characters or blank spaces between characters. So in Python, when you have operations like mathematical operators, you should have 1 space between a variable and the number that gets assigned to it, for example. Or something like this, where I equals I plus 1. That's following the recommendation for the guidelines, whereas things like this are not following the recommended formatting. And I will say, after years of doing Python programming, things that are written in this format are just easier to read. It's just, I don't know, it's just quicker and easier to see what's done when there's space between the operators and the variable names. These are really short variable names, but when you get longer variable names, it's easier to read with the white space. And it's also suggested to avoid extraneous white space. So yes, I think you could run this Python code like this, that the print space parentheses hello. If we go back to our notebook here, this does work. It's not invalid syntax, but it's also not recommended. You shouldn't have a space between the name of a function and the parameters that are given in the parentheses after it. It's also suggested to have only 1 statement per line. So you can use the semicolon character to put things onto a single line, but this is not recommended, again, because it's just more difficult to read and follow what's going on in your code. And there are some things that there is a reason why this is not so strict in Python about everything is it's a little bit of a topic where there's a recommendation, but there are exceptions to the rule as well. So there's an example on the course page about things like list comprehensions, which can make your code much shorter. You can basically do the same thing that's written here on 3 lines on a single line using a list comprehension. But this would actually be the typical recommended way of doing it in Python. And for us, at least, we haven't covered list comprehensions and we won't, but there's an example there if you're interested just about the kind of idea that shorter is not always what's recommended. But it can be nice to not have your code be 3 times longer than it needs to be in terms of numbers of lines. So yeah, you can have a look through the good coding practice, the PEP 8 guideline we recommend you follow. It goes into much more detail than we need in the course, but certainly for things like the spaces between operators and values, the number of spaces for indentations and things like that, line lengths, those are all good things for you to follow. But yeah, let's have a few minutes to look at our exercise for this week. Exercise number 3, no surprise about for loops and conditional statements, due next week at the start of class. And there's 4 problems in this week's exercise, and they are in 4 separate notebooks. Actually, there's 3 problems really and 1 optional problem. So let's open these up so you can see what we're working with. And the first problem is one that is related to batch processing. So it's a common thing and part of the reason to learn a programming language like Python, that you might have a huge list of files you want to go through and do the same operations on every file. Read in the data, do some kind of analysis, and modify it in some way and save the output. So here we have an example of a case where we want to create a list of file names that would be processed in a batch processing type of operation. We don't know how to read files yet, so we're not going to actually do the reading of the files, but we're going to create a list of files that should, in the end, have a Python list that your code produces that says station_0.txt, station_1.txt, station2, etc. in a Python list. And you can use a for loop to do that. That's basically what you're asked to do for the first problems. Create a list of hypothetical file names that you could then read in and do something with. And then there's a couple questions about this, just about your understanding of things like for loops. That's kind of free answer at the end of that first problem. Problem number 2, I mentioned that we could classify things like temperatures. Well, that's exactly what you're going to do in problem number 2. And that is to classify temperatures into 4 different classes. So cold, slippery, comfortable, and warm. So cold in this case would be temperatures that are less than -2 degrees Celsius. Slippery would be temperatures that are warmer or equal to -2, but less than +2. Comfortable would be things that are between +2 and +15. Obviously, this is skewed towards Northern European standards. And warm would be temperatures that are greater than +15. What you're given here is a list of temperatures. I think it's 3 times a day the temperature was recorded at the Malmö airport from April 2013. So you have these temperatures in a Python list, and you're going to loop over that list and then check what the temperature is and classify it as whatever it was. Was it cold, slippery, comfortable, and warm? So you're going to put each one into a list of cold, slippery, comfortable, or warm temperatures. And in the end, you will then check to see how many times it was slippery during the month of April, or how many times it was warm or cold. And then you're given a couple questions here, just again about what your general understanding of conditional statements is at the end of this exercise. The third exercise problem is about allocating locations. So here we have points on a map of Finland indicating locations of the Finnish Meteorological Institute's observation stations that are 70 years old or older. And your task is to take the locations, latitude and longitude of these different stations and use that to determine which ones are in the northwest, which are in the northeast, which are in the southwest, and which are in the southeast. This is done purely on a sort of geometrical thing of just putting some arbitrary center point and then dividing things north and south and east and west of that point, but to allow us to classify the stations into these 4 different regions. The idea with the problem is to figure out, were these stations equally distributed in the different zones, northwest, northeast, southwest, and southeast, 70 years ago, or were they distributed in an unequal way? Here you have 3 lists. I think there's 34 stations or something like that. So for each one, you have its name, you have its latitude, and you have its longitude. You have the point, which is the kind of arbitrary centroid at 64.5 degrees north, 26.3 degrees east as the latitude and longitude of that center point. And then you have 4 lists where you're going to divide these stations into the 4 lists depending on where they are geographically relative to that central point. So you do that, and at the end, if you want, there's an optional chance for you to see like what percentage of the stations lie in the different areas. So you could do that part 6 if you're interested to see how evenly distributed they are based on the percentage of stations. And finally, problem number 4 is optional. Doesn't affect your grade if you do it or not, but if you're up for a challenge, it's about using nested for loops. So it's possible to put a for loop inside another for loop. And using that idea, your task is to create this sort of American flag type pattern that you can have printed out to the screen from using a couple for loops. So I think I'll just say that. You can have a look at the problem if you're interested. It is just kind of a bonus thing if you're up for a challenge. And normally we start next week's class by just going through how to do this in case you're interested. But yeah, that's I think everything for exercise number 3. Are there any questions? All right. If not, we will have exercise sessions as usual on Thursday and Friday. And if you've got issues that don't manage to come up in either of those 2 places, you can always put something into Discord for the week 3 channel if you've got questions or whatever about the exercises. And otherwise, we'll continue next week by talking about functions.